In this video, I'm going to focus on quantity variances for both material and labor. I'm going to assume that you watched the prior video where I covered the price variances, and in fact, you can see up here that I left the information for the material price variance. And again, this is going to be a very similar problem to one of your problem set problems. Because I'm assuming you watched the first video already, I'm not going to re-explain the setup of the information here to the left. I'm just going to dive into doing the calculations. The basic formula for any quantity variance, no matter if we're talking about material, labor, or variable overhead, is this. It's the standard price per unit times the total actual quantity of that input minus the standard quantity, total standard quantity of that particular input. For the material quantity variance, it's going to be the standard price per unit, and in this case, it'd be the standard price per pound, times the total actual quantity or total actual pounds of material minus the total standard quantity. So let's go ahead and again isolate these different variables. We've got lots of information swimming around here on the left. Our standard price per pound is $2.40 per pound. That's what we anticipated paying per pound of material. Our actual quantity is going to be the same as what we had when we were calculating our price variance for material. It's going to be 17,500 pounds. Now I'll make a point here. The reason why the actual quantity in pounds of material is the same between the price variance and the quantity variance for materials is because they mention in A that we did actually purchase 17,500 pounds, but in B they also mention the quantity purchased is the amount also used. So they're the same. If this problem had been different, for example, if this problem had said in B that we only use 17,000 pounds of material, then instead of listing the actual quantity for the quantity variance as 17,500, the amount purchased, we would have listed the amount used, 17,000 pounds used. So that's a big point. Early in the chapter, it acts like the amount purchased is always the amount used, but we got to think about in the real world, that's not going to necessarily be the truth. So when we get to the material quantity variance, take a look. If the actual quantity used is different than the amount purchased, make sure in the quantity variance that you're using the quantity used. While in the price variance, you use the quantity purchased. So just want to make sure you understand that. So let's keep moving on. The next quantity we want is what was the standard total quantity of material that we thought that we were going to have to use for these zooms that we produce. Well, that's not given anywhere. We're told that we anticipated using 6.4 pounds for every zoom, but that's per zoom. We want the total anticipated material for all the zooms we produce. So we're going to have to do a calculation here. In B, we say that we produce 2,500 finished goods. Well, if I multiply that times the 6.4 pounds that we anticipated per unit, I get that we anticipated we were going to use 16,000 pounds. So our standard total quantity of pounds of material is going to be 16,000. Again, let's work through our formula and execute this. Material quantity variance is $2.40 standard price per pound times the actual quantity used of 17,500 pounds minus the standard quantity that we anticipated of 16,000 pounds. $2.40 times 17,500 minus 16,000 means we use 1,500 more pounds that we anticipated. 1,500 times $2.40, we get a material quantity variance of $3,600. And again, instead of plus and minus, let's think in terms of unfavorable and favorable, and let's step back. If we thought we were only going to have to use 16,000 pounds, but we actually used 17,500, 1,500 more pounds at a price of $2.40 per pound, that's a bad thing, correct? Using more materials is a bad thing. That means it was more costly. So this is going to be unfavorable. Again, thinking about the conceptual concepts here in addition, who's usually responsible for this? Usually it's going to be the production manager, the plant manager that's going to be responsible for this. What could have caused it? Well, if you look in combination with our material price variance being favorable, well, maybe we asked for really cheap material, low quality material to be purchased, and it ended up causing us to use a lot more material because it happened to break. That could be it. It could be our production managers aren't really supervising or training our employees correctly, or our maintenance people aren't making sure our machines are up, working correctly. So we're using a lot more material than we anticipated. That could also be a reason for us using more material and having an unfavorable material quantity variance. Now let's go ahead and move on to labor. And again, I'm assuming you already looked at the prior video where we calculate a labor rate variance of 475 unfavorable. And then we're going to focus on our quantity variance for labor. Our general formula is still standard price times actual quantity minus standard quantity, but our lingo is just a little bit different. Instead of a quantity variance, for labor, we call it a labor efficiency variance. Same thing, just different terminology. And similar to when we talked about our price variance for labor, we don't call it the standard price. When you talk about your employees, you don't usually talk about prices, you talk about their wage rates or the labor rates. So we look at that in terms of standard rate. Multiply that times the actual quantity of labor hours minus the standard quantity of labor hours that you anticipated. So again, let's isolate our different variables to make sure that we executed this correctly. What's our standard rate of what we thought we were going to pay per labor hour? That information is given up above. We thought we were going to pay $11.50 per hour. What's the actual quantity of labor hours that we use? That information is given down here in C, and it's 475 actual hours. And we want that in total in this particular quantity. What's the standard quantity that we thought we were going to use? It's not given anywhere directly, so I'm going to have to work that information out. So what I'm going to do, very similar to what I did for material, I'm going to take the actual number of finished units that I produce, that's 2,500 zooms, multiply it times the standard rate. In this situation, it'd be the standard rate of 0.25 hours per zoom. 0.25 hours per zoom times 2,500 zooms. I thought I should have used 625 hours if I produced 2,500 zooms. So my standard total quantity of labor hours is 625. Let's go ahead and execute this. Labor efficiency variance, standard rate 1150 times actual quantity of 475 total hours minus standard quantity total hours of 625. 1150 times, in this situation, it'd be a negative 150 because I actually used 75 hours, but I thought I was only going to use 625, so I saved 150 hours. 150 hours saved times $11.50 gives us a total labor efficiency variance of $1,725. Again, I don't think in terms of negative and positive when I'm doing these different variances. I think in terms of unfavorable and favorable. Is this a good thing or a bad thing? It's a good thing that we use less hours, at least on the surface. We used 475 hours. We thought it was going to take 625, so we saved 150 hours at the standard 1150 per hour. So total dollars saved is 1,725, and that's going to be favorable. Again, conceptual, who's typically responsible for this? It's typically our production or our plant manager. What might have been causes for this? Well, it could just be that we had really trained our employees well and supervised them very well, and again, it ended up taking less hours. It could be a situation, and especially when we look at our labor rate variance previously being unfavorable and looking like we paid employees more, maybe we gave them a pay bump and they were just really happy compared to what they were before and they were a lot more productive. The other reason could be that maybe this unfavorable rate variance was because we use more skilled employees or more employees with more time on the job. So we had to pay them more, but again, they were much more efficient than we anticipated, so the amount of time that they spent was much less. That could perhaps be a cause for a labor efficiency variance being favorable.